All right, let's look at how to find absolute maximum and absolute minimum of a function on a closed interval from a to b. All right, so there are three steps. First steps, find the critical values, all critical values. All right, and the second step, evaluate the function at all critical values on that interval, and also including endpoints, which is a and b. Right. Third step, which is the last step, pick the largest number for absolute maximum and pick the smallest one for absolute minimum. Right. So let's do that. All right. So here's an example. F of x is equal to quantity x minus 1 times quantity x minus 5 cubed on a closed interval from 0 to 3. Right. So first we have to find a critical number. So let's take the derivative. So f prime of x is equal to, right, derivative of x minus 1, so I'm using the product rule, is 1 multiplied by the second, so it's quantity x minus 5, right, and the cubed, plus first guy, which is x minus 1, right, times the derivative of the second, so 3 in front, keep the same quantity x minus 5, subtract 1 from the power, so it's 2, then multiply by derivative inside, which is 1, so I'm not going to write anything down here. Right, then let's factor out the common factor. Right, so you can see that here there's quantity x minus 5 squared. Oops, I wanted to use a different color. Right, so here x minus 5 squared. There's actually 3 of them there, so I'm gonna just circle this so that I know that there's another x minus 5 there. So I'll pull out the quantity x minus 5 squared. Right, then what's left is, right, so there's going to be another x minus 5 from the first term, so I'll put that in, x minus 5, right, and then there is going to be 3 times distributed to x, so there's going to be positive 3x plus 3x. Alright, also 3 distributed to negative 1, so it's going to be, there's going to be negative 3 there. Right, so I took care of every one and I clean up a bit, and you can see that this is going to be a 4x minus 8, so maybe I should write that down. So this guy right here is a 4x minus 8, and both of them has 4 in it, so I'm gonna pull 4 out as well. So here, pull out 4 from there, so you have a quantity x minus 5 squared. Right, pull out 4, so you have x, pull out 4 from negative 8, so it's negative 2. Right, and we're gonna set that equal to 0. Right, so we have a critical value x equals from here 2, and from here we have 5. Right, those are the critical values. Right, and then step 2, we want to evaluate a function at all critical values on that interval, and including endpoints. All right, so here's number 2. All right, so we have to look at the first endpoint would be here 0. Right, oops. Right, we have a 0 here, so we have to look at that. So you have f of 0, we're gonna evaluate, and also we have a critical value, which is 2 is the next one, so we have to look at f of 2. Alright, Then also we have to look at another number is 3, so that's the other endpoint, so we have to look at the f of 3, right? And even though here 5 is a critical number, but 5 does not belong to this interval from 0 to 3, so we do not need to look at x equals 5. So those are the three values we have to come up with. Right, so let's do that. Right, plug in 0. Right, 0 here, it's -1, so it's -1 times 0 is a -5 cubed, right? So -5 cubed is going to be -125 and times -1, so it's going to be +125, right? And plug in 2, right? If you plug in 2 here, so that's going to be 1, right? Plug in 2 here, so it's -3 cubed, right? So that's going to be -27, right? Plugging 3 there, so it's going to be 3 minus 2 is 3 minus 1 is 2 times, so you have a 3 minus 5 is so a -2 cubed, so that's going to be -2 cubed is -8 times 2 is -16, right? So it's easy to determine. All right, absolute max value is obviously there's only one positive number, 125. So this is the absolute maximum. Right? If you're looking for the absolute minimum, smallest value is -27. This is going to be the absolute minimum value. Right? So those are the absolute maximum and the absolute minimum. Right? So this is how you find the absolute maximum and absolute minimum of a function on a closed interval. Right? Make sure that it's a closed interval. Right? Like this one right here. Right? That's it. I hope that this was clear.